All right. Good morning, everyone. Welcome to day 17 of Math 133. Today we're going to be working on the Chapter 7 review, and you'll find that in your course pack on page 457. Uh, don't forget to do the 8.1 lecture notes. So again, try to get those done before Monday. They're due on Tuesday, but if you get them done on Monday, that'll be good because Elaine is going to cover some Chapter 8 stuff with you guys. So a couple of announcements. On Tuesday, we had some internet issues. So the Chapter 7 project, uh, we were able to do it in the morning class, and it's been recorded, and you can go and you can watch that recording here. Um, but the evening class, my internet just completely crashed on me. So anyway, so that assignment is, if you need a little more time, that's fine. It's not due today. If you've already turned it in, good job. But otherwise, I'm going to move the deadline out to Tuesday for that one. So you can see that I haven't actually adjusted that yet. I can go into, I'll have to go into Canvas and make that adjustment. Um, and then for um, the lecture notes that were assigned last week on Thursday, I also pushed those out, so those are due today. Okay. So again, I'll need to go in and I'll adjust those dates for you. So, but anyway, so hopefully the internet's back up and running. Things are fixed. So, yeah. So as I said, today's the Chapter 7 review. Um, and we can also take a look at some of the questions from the midterm today. I've gotten everyone's midterm graded, so make sure you go and take a look at your grade. I've also gone through and I'm not completely caught up on the other grading. Like, for example, I haven't touched the sample midterms. The sample midterms, those will be part of your worksheet grades. But a lot of the grades have been done, including anything that's more than 3 weeks late. Remember that if it's more than 3 weeks late, it's no longer going to be accepted. So those zeros have been put in. So take a look at your grade. It's, as I said, I'm still grading some things, but it's going to land somewhere around that area where you're at right now. In terms of passing the class. So if you didn't do very well on the midterm, that's, you're not the only one. A lot of people struggled with the midterm in comparison to their, projects and worksheets, because the projects and worksheets, we work on them together. We're going to do the Chapter 7 review worksheet today so that you get, all of everything on that correct, because I'm going to show you how to do them. So the sample midterm, not the sample midterm, but the sample midterm, you worked on that with me and Elaine, so you probably are going to, do well on that. But the actual midterm, yeah, you're probably going to score a little lower. So that said, if you are concerned about your grade, feel free to reach out. We can talk about, what your options are. So the best way to keep up is you are welcome to work ahead on the lecture notes. So even though I'm assigning 8.1 right now, you could go and look and say, okay, I'm going to also work on 8.2 so that I don't fall behind. Okay. Um, and then for the um, for the midterm, um, so the midterm makes up 30% of your grade. If you completely got, a zero on that, you could still pass the class even if you fail the midterm. Okay. Just you need to make sure that you study for the final. So you can't pass the class if you fail the midterm and you fail the final. Okay. Anyway, but if you are concerned about about your chances of passing the class, we can have a conversation around that, and we can look at what your final grade needs to be in order to pass. Um, if you are considering withdrawing from the class, again, I'm fine having a conversation on that. withdrawing from the class is an option. It might affect other things like financial aid and stuff, so just be aware of that. But um, this class is a lot, right? We're halfway through, and so at this point, like there's a lot of stuff to do, and so we've got another month and a half. So if you're grades in the 80% range, 90% range, then you're good to go. You know what you're doing. Okay. So okay, cool. So today, as I said, we are going to work on the chapter 7 review on page 457. So in Canvas, if you click on the chapter 7 review worksheet, there's a link here for the data sets. But for the most part, there's not going to be anything for chapter 7 and chapter 8. So you'll notice like there's nothing really here. But we are going to be using StatCrunch a lot for this chapter. Okay. So you're going to want to type in statcrunch.com and then sign in. And then once you've signed in, this orange button here will light up, and you're going to click on that, and that's going to bring you to statcrunch.com because that's where we're going to be using the normal calculator. So on page 257, so in page 257, which is part of your exam notes packet, there's information about chapter 7 and the StatCrunch path that you're going to use, which is stat calculators normal. Okay. So stat calculators normal. Okay. And we're going to be getting pretty familiar with this tool. So this is the normal curve. Okay. So a normal curve, there's other types of curves that we're not going to talk about necessarily in this class. So if I go to stat calculators, there's all kinds of stuff here. There's Poisson and there's chi-square and Cauchy and if you get into some higher level statistics stuff, these become a little more useful. We will get a chance to look at the T calculator in a later chapter. But for now, we're just going to focus on the normal one, okay? And the normal one is very powerful, okay? It doesn't always fit with real world data. Last time we met on Tuesday, we were looking at baseball home runs. And the baseball home runs did fit a normal curve. It was very symmetric. It went up, it went down, it had two tails on both sides. But we've definitely seen a lot of data sets that don't follow this shape, where they're skewed to the left or skewed to the right. Yes. So when you have skewed data, you can't use the normal calculator the way that you can for other for some things. But when you do have this shape, when you do have the normal calculator, there's a lot of things you can do with it. Okay. And the reason why is because you only need the mean and the standard deviation, and you're able to convert those into probabilities. Okay. So on the x-axis here, these are actually z-scores. This is actually a z-axis. Okay. It says x, and we'll use Z and X a little interchangeably. When I talk about, you can see on page 257, there's steps for what do you do if you have a Z-score, and there's also steps for what you do if you have an X value. So for the most part, the steps are the same. Okay, just be aware that you need to pay attention to whether you have an X or a Z value. Really, the only difference is the mean and the standard deviation. When you have a z-score, your mean is 0 and your standard deviation is 1. Okay. When you have an x value, you're going to have to put in the mean and the standard deviation. Okay. And those will be given to you in the problem if you do have x values. Okay. So just be aware of that. Anyway, but the power of this normal curve is that if you have a z or an x value, there is a corresponding probability that goes with it. And that probability is this red area here. So right now, if I was looking at I want my z value to be less than 0, then there's a 50, it's 50%, okay? But if I was to change this and say, okay, I want to look at between, and I want to look at between -2 and +2, we remember from chapter 2, chapter 2 and chapter 3, that if you're within 2 standard deviations of the mean, then that's 95% of your data. Okay. And that's and that was a rounded number. It's actually 95.45%, but 95% is just kind of a good rule of thumb. Okay. But now that we have access to this calculator, we can get a little more accurate than just saying, oh, 2 standard deviations is 95%. 1 standard deviation was 68%. Okay. Um, okay, so uh that all said, um, let's take a look here. So let's go through and see if there's any hints. There's not going to be a lot. Most people don't really struggle with chapter 7, but this chapter 7 stuff is important for the more complicated concepts we're going to be looking at for chapter 8, 9, 10, and 11, okay? All right, so chapter 7. The following graph comes from a random sample of data. Is it reasonable to assume that this sample is drawn, that this sample is drawn from a population that is normally distributed? So uh, the dots here, so we have these dots here, right? This is a scatter plot, and we've done a linear correlation like we did in chapter 4. And you'll notice that these dots are very close to the line. If we were to look at our correlation coefficient for this, do you think this would be strong positive, moderate positive, weak positive, strong negative, weak negative? What do you think? The correlation coefficient. Yeah, this is definitely strong positive. When your dots line up this closely to the line, it's strong positive. Thank you, Andrew. So when that happens, you can assume that yes, this sample data came from from a normally distributed population because the points are mostly linear. Okay. Why are we asking that? Well, so just like when we were looking at the baseball data, when you were just looking at a column of numbers, it's not obvious if that data is normally distributed or not. Okay. And so by graphing it, and if you have a scatter plot and you graph it and you get a linear distribution like this, or if you graph it using a histogram and you get this kind of bell shape, then you can assume, yep, this is a normally distributed population, okay? Which means I can use the StatCrunch calculator, okay? Right. Question number 2, consider the normal curves. Which graph has the largest mean, and then which graph has the largest standard deviation? So let's see, so back here in Canvas, there on day 16, we didn't really cover it, but there is a normal curve in Desmos. We're, for the most part, going to use the normal curve that's in StatCrunch. But the normal curve in Desmos has the advantage that you can kind of move things around. So up here, I can shift my mean bigger or smaller, and I can shift my standard deviation bigger or smaller. So when I shift my mean higher, you'll notice that all it does is it moves the curve to the left or to the right. It doesn't change the shape. The mean is the center of the curve. The center is the highest point. So if I put my mean right here at 1, my highest value is at 1. So looking at question number 2, which of these curves has the largest mean? You're looking at which one is farthest to the right. Does that make sense? Which of the middles, right, the highest point? So the highest point in this case is labeled here at D and A and B and C. Which of them is farthest to the right? When I ask which curve has the largest standard deviation, so if I make my standard deviation bigger, what happens is it starts to spread out. So it gets shorter and fatter. When I have a very small standard deviation, it's really tall and really thin. Okay. So a large standard deviation, which one has a large standard deviation? That means it's short and fat. That means it has a large standard deviation. Tall and skinny means it has a small standard deviation. So which graph has the largest mean? Andrew, you are correct. And question or part C, answer C is farthest to the right. And which curve has the largest standard deviation? Would be A because it's short and fat. Okay. And explain how you can tell that's actually the explanation. So farthest right. And this one is the widest. Okay. All right. Page 256, or sorry, 458. Not even close. 458. So for all of these, you're going to be using the information on page 257 in StatCrunch. Okay. Um, when you're doing a percentile, for percentile, we always round down. Okay. For anything else in this class, we round just like normal, but when we're talking about percentiles, we're going to round down. Okay. Okay. So for question number 4 here, we have 3 different numbers to find. And so every single, and so for this one, uh, our x-axis here is an x-axis. We have x values, okay? Um, oh, no, I'm wrong. Nope. This is the standard normal curve. When you hear the word standard normal curve, that means the mean is 0 and the standard deviation is 1. Okay, so these are z values. So even though it says x, these are z values. That's fine. Um, so every single x value or z value um, corresponds to a probability. Okay, so for example, what's the probability that the z value is above negative 1.24? Okay, so this z value is somewhere on the x-axis here. Here's 0, so negative 1 is somewhere around like here. Okay. And we want the probability that z is above that. So we want to find this probability, so this shaded area. Okay. So every single z value has a corresponding probability that goes with it. And you're going to use StatCrunch to find those. And you can either, if you have a probability, you can find the z value, or if you have the z value, you can find the probability. But if you don't have either one, well, you're kind of stuck. So for this question, I have an x value and I can find the probability that goes with it. Over here, I don't have either of these. So if I don't have my Z value and I don't have my probability, then how am I going to find these? Well, if you add these three together, A1 plus A2 plus A3, what do you get? If you add up this shaded area, and this white area, if you add them all up, what do you get? What's the total area under the normal curve? What do you usually get when you add up all your probabilities? You get 100%. That's right. You get one. So if we add this plus this, we get one, which means if I know two of these numbers, I can find the third one. Just do one minus this minus this. Okay. All right. You'll do the same kind of thing on question number 5, where again, I have three numbers I need to find. But this time, I'm not going to be able to start with A1 and X1 because I don't know either of those. You need to start with two values where you know one of them. I have an X value right here, and I have a corresponding probability that I don't know that goes with it. So I want to start with A3 this time. So start here, okay? And then the last thing is page 460. I think all of this is very similar, except this time um, my x-axis here is actually an x-axis, not a z-axis. Um, so they say that the average jail population in the US was normally distributed with a mean of 652, a standard deviation. So this time my mean is not 0 and standard deviation of 1. This is not the standard normal curve. It's just regular, any other normal curve. So when I'm putting my stuff into StatCrunch for this question, make sure you change your mean and your standard deviation. Okay. But otherwise, that one's pretty similar. So, as I said, most people don't really struggle too much with this chapter. So, I'm going to stop the recording and we'll dive in. Um, Before I do that, there's one more announcement I've almost forgot to make. So, Halloween's coming up, but that's not the exciting thing. The exciting thing is we have a candy project coming up. On November 4th, we are going to talk about candy. So when you're going and you're buying all your Halloween candy, you need to buy just a little bit more candy for math class. So um, on November 4th, you're going to need to have a package of M&Ms and a package of Skittles. Okay. Let me open this up. So uh, we usually wait until just before just before the project to announce because otherwise, you don't want candy sitting around in your house. It gets eaten. Kids find it, spouses find it. So, I mean, sometimes the students themselves eat it. They're like, I can't wait. So, you will get to eat your candy after we've done the project. So it's not going to be sitting around for very long. But you need one bag of regular colored M&Ms. So it can be any type. So M&Ms they do their colors the same regardless of whether it's like the peanuts or the peanut butter ones, those are my favorite, or the pretzel ones or whatever. They just need to be the ones that have the normal six colors, red, blue, yellow, green, orange. Um, so that's fine. Uh, the Skittles, on the other hand, the Skittles do have to be the regular colored Skittles, which means they have to be the ones in the red bag. Sorry, I know some people are like, "Oh, I wanted the fun Skittles." So, they need to be the ones in the red bag for the Skittles because we need to make sure that the colors match. And in Skittles, they have a red, a yellow, an orange, a green. Um, but some of the other crazy bags don't always have those colors. So, uh, your bag that you buy needs to be larger than the regular size bag. So, the regular size bag I think is like 1.5 ounces, 3 ounces, something like that. Um, so if you're again, you can buy whichever type you like, but you need to have somewhere around um s- somewhere around like 100 M&Ms. I'm not expecting you to go and count them, but if you get the bag that's, I believe, 5 ounces or bigger, then you're good. And the same thing with the Skittles. So, if you do buy a bag that's very small, just the normal size bag, that's fine. It's just going to make your data a little more unreliable. On the other hand, if you buy like the giant thing that's like, I don't know, like what do they have? They have like like a pound of Skittles or something like that. That's a lot. You're gonna have a lot of counting to do. But your data will be super accurate. So anyway, um, I'll mention it again when we meet on Tuesday. Give you a little more information if you need, but otherwise, just a heads up on that. So, all right, let's jump back to our Chapter 7 review.